Hello, so it's Mesomachi here, and together with a fellow instructor at Special Maths Academy, Pius, we will be discussing the solutions to the just concluded 2024 Special Maths Contest, the first round. Please share this video, like, comment, and don't forget to subscribe. We need those subscribers. Enjoy the video.
Yeah, okay. So yeah, good evening, Mr. Pius. So we continue our discussion with about the Special Maths Contest 2024 first round.
Right.
Yeah.
All
So
right.
we
So
have problem 23 here. So let's get right into it.
yeah, so we have problem 23, one of the later problems. So it's slightly on the harder side based on the contest. So this is geometry, right? And for this contest, we don't have diagrams, so we would have to sketch a diagram to properly analyze this problem, and then we can consider the options after that. Yeah. So just from the outlook of the problem, what do you think? Do you have like any observations?
Okay, so first of all, I seen like the letter M in a geometry problem, for Olympiad. I don't like it. I rather reserve letters like M, N for either number theory or
Integers.
algebra. So in geometry,
Right.
I want to see actual numbers, actual, unit lengths. But also, I think what else can I say about this problem? I just looking at it, can also look at the fact that we have omega, a circle, is just on its own, not necessarily defined by points on the circumference. So
Yeah.
it's not a common style of proposing problems in geometry. I think I can say that.
Yeah.
But yeah, the question
Yeah.
looks intimidating to an extent. I think I can say that. Just by first.
Yeah, I was waiting for that. All right. Very true. Okay. So yeah, like you observe rightly. So usually most geometry problems are based on like a triangle, and then other things expand from that triangle, right? But this problem actually is it's not too fixed on this triangle that was implied here, but actually more so on the circle. So let's sketch and see. So we'll start with the circle. Um, so for now, we'll just start with a very rough sketch. If it's not good enough, we may have to redraw.
Yeah, that's another thing about geometry problems.
Yeah. For now, you just need to have an idea of what you're even dealing with. So
I think there was a geometry book I was reading back in the day, and I think there's a quote from it. It says geometry is about, so this is not verbatim, so I'm just paraphrasing the quote. It says geometry is about doing correct mathematics from wrong diagrams.
right. So that's actually interesting code, because most often we'll not really have like a correct diagram. The diagram is already influenced by the conclusion from the problem most times.
Yeah.
Yeah. So here we have, so there's one part that can throw someone off for this problem, very important, which is this point here, which is that ABC lies in the interior, right? So which is why this circle doesn't have much to do with the triangle. So it's just some triangle inside. Okay. So we have A, B, C. All right. Then now we have to extend. So let me just change the colors a bit so that we can get the differences. So we extend to meet the circle from various points in different directions. So we have beyond A on AB. So beyond A, we go in this direction. So we have here A1. Then from beyond B of the same AB, we get another one. This is B2. Okay. Then next we have on BC. So we extend beyond B first, this way. We get B1. Okay. Then on the other hand, we have C2. Then finally, we have CA. We extend beyond C. We have C1. Okay. So this diagram clearly is not accurate in any way, right?
At all.
So, but at least I think it's coming together gradually. We're already done with 2 of the lines, so it's no longer as intimidating in terms of wordings. But let's see what diagram we end up with. Now, suppose we have that A1, A2 is parallel to BC. So, excuse me, let me use a more sharp color here. So this here is parallel to this. And then A2 is the same length as CA. So that's this here is equal to this segment, right? And then this, they are both equal to 3M specifically. Then now we have B2 is also equal to C2. So this length here is equal to this one here, both of them being this. And finally, we have B1, this over here, and AB, this over here. So they are both equal to X. All right. So these are some very random alphabets like you observed. Now, the value of X supposedly can be determined in terms of M to give one of these options. So we need to work based on this diagram and figure out our value for X. Now, like every other question, since we have the options, if we are strictly working on just getting the result, and we don't want to work with too many variables, we can decide on a value of M whereby all these options will be different. Probably most values of M, these options will give different values. Then we can just use that in our diagram to be a bit more straightforward, right? So for example, you can just say, let M be equal to, let's say 2. 1 may not work too well because of B. So we can, I think 2 should be safe. Then this would be 1. This here would be 6, for instance. This will involve a fraction, which is
just to
16.
clear the air.
So this
So
is
if I
32
may
over
ask,
2.
if I may ask, why won't one work so well because of option B? So I'm thinking because it will lead to a degenerate case.
Yes, exactly. If M is equal to 1, this should just be 0. And that may not be too friendly.
So for the viewers,
and
what I
probably
mean
it's not
by
even going to
degenerate
be the
cases
answer.
is
Yeah.
when you start having things like a triangle being equal for the lateral with one side being equal to 0. So
Yeah.
funny things can start happening when you consider degenerate cases. But okay, let's move on.
Yeah, so the issue with degenerate cases is that it becomes hard to distinguish many elements. Like some lines will now coincide, or some points will coincide, some angles are no longer well defined. So a lot of things get very congested together as like a very simple stuff, but it can go wrong too if you don't take it properly from where it came from. This would be 4. This, for example, would be 9. Now, however, there's a warning I should give on this, in the sense that these expressions we have are not homogeneous, right? Meaning that it has already been, is based on a scale, basically. So if you change the values of M, you don't get the same picture. The picture would actually change. So this doesn't tell us which values of M are actually possible, because we are supposing that we have such a value. It could be a unique value, it could be a range of values, maybe 2 is not good enough. So that could be something you may have to consider.
So I think the fact that it's not homogeneous is probably because there are not, a whole lot of not equilateral, but pairs of similar triangles, something like that. Because if everywhere we looked, there were like pairs of similar triangles, then scale factors would be appearing everywhere, and would have to have some sort of homogeneity. But yeah, I'm just, guessing. I mean, that's just like a gut feeling.
Yeah. So that's it. So one will have to be careful about it. And not just casually do this. So either way, let's just work directly on the problem to be safe.
Mm-hmm.
Because sometimes in the geometry problem, we might work on it without even checking if it's like a possible figure, and that could be tricky. If it's not a possible figure, then any other thing that is not, any other thing can actually come out from it, depending on which angle you work on,
Yeah.
right? So we have to be very careful about that. Anyway, let's work on this one. So do you think there's a need to redraw this diagram? Personally, for me, there's not much need yet to redraw.
And I don't see the need yet. Yeah.
Yeah. So later we may redraw, but for now, I think we can work a bit on this. And then later, if it gets too congested, we may have to take different portions and draw them properly.
Mm-hmm.
Okay. So we have, before we go to X, there are three elements that were given: the parallel part, the equal parts. There are two of them. So for the last equal portion that we're given, they're kind of far off, so it doesn't come off immediately as something we can work with. But we can look on the first two things given. So actually, let me redraw them. So actually, I'll just bring just this portion out of it, just to illustrate what is going on. So here we have this is equal to this. This is parallel to this. So this is a very peculiar shape. So actually, from here we can get a few things, right? This is
Mm-hmm.
P, this is C. So since there we have parallel lines, then this is angles here are equal, and then from alternate angles, I mean vertically opposite angles, now we can also get this. So the first is from alternate angles. So actually these triangles are similar, and in fact they are congruent because the sides that were given to be equal are opposite the same angles. So we have this facing this angle here, right? So these in fact are congruent. We have that A, B, C is in fact congruent with triangle same A. Now to get the angles, to get the labeling correctly, B will correspond with the angle I marked, so that will be A1, then this should be A2, right?
Mm-hmm.
Okay, so we have that they are congruent, meaning that we can actually um, make some progress in terms of labeling this diagram. So this, for example, is also going to be X.
Mm-hmm.
Yeah. And looking at this, it seems like we have like the length of all the segments except for CC1. So at this point, it's important to understand like the nature of this problem, which is actually based on lengths. So we should work on the fact that these are chords in a circle.
Mm-hmm.
And what should come to mind at this point is the power of a point in the circle. Because from this, we're able to get like in a circle, if we have, just quickly, we have two chords that cross each other,
Mm-hmm.
then we get some similar triangles based on cycle theorems. So that gives like some similarities, and we have some relationship in terms of the length. So
Yeah.
more specifically, if we have a circle and you consider only two chords crossing at the point P, then we call the power of the point P to be the product of the opposing line segments. So let's say we have this A, B, C, D as a length,
Mm-hmm.
then the power of P would just be A times C, which also is going to be equal to B times D from the
Mm-hmm.
similarity.
Yeah. Because I
So
was
this
about
is
to
what
ask
we're
you what
going to
power of a
work with,
point is.
right? So this is very
Yeah.
important. So
Mm-hmm.
this is basically the relationship we are going to exploit in terms of each point within a circle. And if we know the lengths of the corresponding segments, it breaks it into. So here, depending on which point we pick, we have 3 points in the circle. So we have three options. We could use A, we could use B, we could use C. Then we can use that to look at the relationships. So
Mm-hmm.
now in terms of where to begin, we have a lot more we know about um we know a lot more about point A, and also yeah, I think mostly point A. We know a lot more about point A. If you look at point B, there's also another portion we didn't get. So let me highlight it. We don't know this.
Mm-hmm.
Even though it's equal to the top one, we still don't know what it is. And then we don't know CC1. So in terms of, so we don't know these two things. So definitely option C is out. We can either start from B or from A, and to figure out the missing pieces, basically. So let's start from A. Let's start from A. So power of point A. So for A, what we have is I think I should just withdraw it, right? What do you think?
Yeah. Okay, let's scroll down and redraw it. Yeah.
Yeah, let me just withdraw it to focus on the division caused by A. So here we have 3M. So this is A2. This is A1. This is B2. So these are on the circle. They have to be on the circle. So this is 3M. Here, this is 3M plus some unknown, which we want to figure out. And then A1, this is X. And then right here, we have two segments together, which will be X plus 4M squared minus 1. So basically, I'll just keep this unknown as question mark, right? So we have 3M plus the so-called unknown is X into X plus 4M squared minus 1. So this is what we have. There's no obvious simplification for this, so let's keep it for now and see what we can obtain from it. Could call this equation 1. Then now let's go to power of point B. So we can look at power point B to figure out the other missing segment. So here we have B. So this is B1, B2. This here is A1, and this here is C2. This is X. This is 4M squared minus 1. This we don't know. So excuse me to call it double question mark.
Double question.
Yeah. I think we know the second component of this. Let me check. Yeah, 4M
squared minus 1.
Squared minus 1. And the other ones. Yeah. So we have 4. So this one is actually a lot easier to simplify because here we have 2x. And what happens in this case would be x into this unknown plus plus this element here is equal to 2x times 4m squared minus 1. So now we actually have something that can cancel out. We can strike out x from both sides by dividing both sides by x. So we have that this plus this is equal to twice of the same element. So
yeah, basically
this is also equal.
Double question mark rather is equal to 4
So we are done with the double question mark. We can get rid of that.
Okay.
So we can actually update this. So this here has the same mark. Also 4m squared minus 1. Right. So now we can look at the final point. This time we've already considered the unknown. So now this will give us like a final relationship that maybe we can use to figure out the first unknown. So let's redraw this. Or C. So here, C is somewhere here. So this is the first unknown. This was unknown, but now is x plus 4m squared minus 1. So this was the second unknown. And then here is also 4m squared minus 1. Then this here, this is A2, by the way. C2. Okay, so this here would be where we have 3m and 3m, so this is actually 6m. All right, just referring to the diagram. All right, so here now we can once again talk about the unknown. So this times 6m is equal to 4m squared minus 1. So we get this. Now we are looking for x, but also had another unknown involved here. So let's call this one now equation 2. So we can just picture this as a simultaneous equation in this is 2 in x and the other unknown. So to make it a simple equation, we can simply substitute value in the second equation to the first one, right? Okay. So to avoid fractions, personally, I don't like fractions. Do you have any thoughts on that? Actually, I hate fractions in some sense.
We can agree on that. We agree on that.
Yeah, great. Great. So to avoid fraction, let me just give an idea of what we can do here. So this is this times 3m. Here we have 6m, here we have 3m. So to kind of balance it so that this is like together it's like one unknown, like a bigger unknown. We multiply the first equation by 2. So just adjust that. So avoid fractions altogether. So that will be 18m squared plus this, which we now have in equation 2, equal to 2x into, if I'm not mistaken, x plus here, 4m squared minus 1. Right. So this becomes this from equation 1. So now we can directly substitute and at least avoid the fraction for now. We have this plus 4m squared minus 1 equal to 2x. And sometimes I don't like writing things that just seem to repeat. I tend to give them like a variable. I'm not sure if I should do that at this stage. Personally, I like doing that to make things a bit clearer. So for example, I would say let this whole stuff here be called y, right? So this will be y into x plus y to x plus y.
Yeah. Fair.
Right? Just to make sure. Yeah. Okay. So we see that we have x plus y, x plus y. We can just expand this in terms of, we are focused on x, right? So just expand this y squared and consider this as a quadratic in x. So we can take everything to one side. Minus xy minus y squared minus 18m squared. So this will be 2x squared plus xy minus y squared plus 18m squared. Okay, so this is what we want. Now we can just put things back together to have a clear picture of what we're doing. So this is 4m squared minus 1, 18m squared. So this is what we get. Now we need to solve this.
Okay.
We need to solve this. Now, if this have like nice factors, then x will be a factor of the first two. So we'd expect x to be a factor of this, meaning this needs to be factorizable.
We hope so. And we want to believe so too.
We hope so. Yeah, I also hope so. Let's see. I hope I didn't make any errors anywhere. If not, then we should be able to get the result. So this is 4. Also, m square appears everywhere, so one can just change m squared too if you are not comfortable with that.
Mm-hmm.
Mm. Is this factorizable?
Let me say 16m4 minus 10m squared plus 1. Yeah, 8 and 2. So,
Because it better be, otherwise we'll have
so
we'll have some
16.
issues. So
So I
we
think
have
it's, yeah.
8, and
Mhm.
then we have 2.
Yeah.
Right. Great. So this would give us an idea of what to expect on the other hand. So let me just rewrite this. I think if we write it like this, it's going to make it easier to at least see the solutions.
Yeah.
So I think it's kind of obvious that this will be one of the values that works.
Yeah.
Because if this is 2m squared plus 1, then this will become 4m squared plus 2 plus 4m squared minus 1. So yeah, so this will be one of the solutions.
Yeah.
Now, the other solution would be negative. So let's call this x1, right? So we know from solving quadratic equations that if we add the two
Yeah.
roots, the sum of roots, then it should give minus, let's say we have this equal to 0. If you're solving this one, we have two roots, x1, x2, then the sum of roots
x1 plus
would
x2
be
should be, yeah.
minus this. So we have minus 4m squared minus 1
Can't we
over
just
2.
infer it directly from product of roots? What do you think?
Okay,
Yeah.
that's even better. That's even better.
We've got one positive root
Thanks.
and we know that the product is negative. So
Yes, the product is actually a lot better. Let's go with the product. And that makes it even clearer why it's negative.
yeah.
So this would be C over A.
Yeah.
So we have x1, x2 would be minus of what we factorized. So here we can see the other factor will be just negative of the cofactor. And this wouldn't make sense in terms of lengths. So this is not
Yeah.
possible. So we must have this as our x, just one x. Yeah. So
Interesting.
now at different points, one can actually try some options to confirm these equations in terms of, since it's like an objective, right? So
Yeah.
there are other ways we can go about this instead of just solving. At this point, we can try to see which options make sense here
So
for
first of all,
factorization.
can
Yeah.
we see that? Can we confirm that what we got is in the
Go on.
options?
Yeah, let's look at the options again. So this is E, right?
Yeah, option E. It's our guy.
Yeah. So one can actually, if at different points, one can test these other options to see if they even make like any sense in terms of polynomials. You can view this as trying to have polynomial identities, since those are like expressions in terms of m. Then this, if we pick our value for x, it's going to also give you like a polynomial in m. And so, and in that case, we expect this to be at least like either a polynomial or some kind of fraction, at least in terms of m. And then also here, We expect this to also give something reasonable. So actually from the second equation, we can use that to figure out the question mark and then complete it here. Or we can just come to this portion here where we already have things simplified a bit and plug it in. So at different levels, we can test values and eliminate them. So for instance, maybe let's test one of them and see how that goes. Can you suggest to try one?
I mean, I think
Yeah.
I can safely say that option A and option D are like dummy options in the sense that at least with the third equation we got, they don't agree with the degree of the polynomial. So let's test option B. I think that's a more, I don't know, convincing option than the others. 2m
Yeah.
squared minus 2.
So, and for C, C may look like it's very random, right? But it's not so random also, just to point out. So C is actually this guy over 2.
Interesting.
So anyway, B looks a bit more friendly. Let's try B and see like how it may look like for an option that doesn't work, right?
Okay.
Let me erase some things here to make space. Okay, so let's test option B. So for B, we have that x is equal to 2m squared minus 2. So equation 1 would just reduce to is equal to, this already factorizable by itself.
Yeah.
So which is nice. And then here would have 6m
6m
squared
minus
minus
3.
3. Also a bit factorizable. But ultimately nothing too special in terms of simplifying this further. Then for the second one, we have this times 6m. Already factorize this part. And here is the same stuff again, right? So we have 6m squared minus 3. So at this point, probably you still need to do the same thing to simplify. But one thing we can do though is to check the
behavior of the polynomials on both sides. I mean,
yeah, on both
I want
sides.
to get here. For instance, I think
Yeah.
for the second option, I think we can see, okay, we can see that 6 does not divide the polynomial on the right, but I mean, we could, the question mark could be a polynomial that does not necessarily have integer coefficients, so that's
Yeah,
not.
so that may not be
Yeah.
very accurate. So more specifically, if we divide both sides by 2 here, we can get rid of this part that we're not sure if it's a fraction or not. So now it's almost right. So the others have polynomial
I see.
coefficients. So this needs to have integer coefficients,
Yeah.
and it doesn't from the constant term. So this would fail right here because it needs to be an identity.
Yeah.
So for example, that's how we may just check. So I think the last equation we got is probably more useful. This kind of equation will be more useful.
Yeah.
But writing like this actually helps quite a lot. Writing like this helps quite a lot.
Yeah.
Then we can also try. Yeah, I think I can just leave the rest for the viewer to
The
explore.
left is red. The left is rest. Is
The
what I
rest
was
is
going to
left.
say. Yeah, the
Yeah.
rest is left as an exercise to the viewer.
Yeah.
Okay,
Please enjoy.
so
Yeah.
let's see how our participants fared in this. So I think I'll prepare the plot to discuss this. Okay.
You ready?
Not yet.
Okay.
Okay.
So this question it requires like one to actually put in some work to get
Yeah.
things out. So no much of like just tricks per se, except you have some intuition of what the answer might look like. But to avoid all this algebra, like we mentioned before, you could just pick some number. Based on how we worked on it, you see that M doesn't have to be too special because we need some identity at the end of the day. We expect some identity. So we can almost safely pick a value for M, and that will make all this calculation a lot more straightforward.
Yeah.
To be a lot more straight. So that would maybe I should even just write a bit about that. It will look something like this. Let's say M is 2, for example. Then the diagram will reduce to. So by the way, this is a faster way of drawing the diagram, right? It's 3 chords. Then this will be 6. That's 3M. This will
So
be
start from
6. This
the
will be 6.
second.
4M squared. Yeah. 4 squared minus 1. This is 15. So here is 15. Here is 15. And then this is X. This is X. This is X. So from power of a point, we will get that this also has to be 15, which we did before. So it wouldn't be too different. And then that's working based on this power of a point. Then from this other one here, we just get that no, let me treat C first. So for C, we only have one X appearing, so it'll be linear. So for C, we'll have 15, X plus 15 is equal to the unknown times 12. So the unknown is simply 15, X plus 15 over 12. We can cancel a bit to have 5, X plus 15, which is 5X plus 75 over 4. So with that now, we can take the power of point A to give 6 into 6 plus this here equal to X into X plus 15. So we have 36 plus 6 into this over 4. 2 cancels here. We have 3.
Yeah.
So that'll be. So this will be a lot more like you don't have to keep track of like polynomials and all those substitutions
Yeah.
and stuff. So you only need to clear this fraction 2 once again. So we see that that is still common. So we can avoid the fraction multiplied by 2. And then we have 2x squared here. Here we have 30x. So 15x. This is some big number. 2 to 5. And so we're almost done. At least from this, one can check the options a lot more easier.
Yeah.
Which answers can work for this. Yeah.
Mm-hmm. Yeah.
So
Okay.
this is like another way to work on
Yeah.
it. So now let's look at the
Performance of the participant.
performance. Exactly.
Yeah.
Sure.
So I'm ready to share my screen.
Okay.
So can you see my screen?
Yeah, it's visible. It shows your meeting screen.
Oh,
So you should check the screen you're sharing. Yeah.
okay. Let me share again. Okay.
Okay.
Yeah.
It's visible now. Cool.
So we can see
Okay.
that
Yeah.
a lot of the contestants chose option C.
But
But
that's interesting.
I think it didn't go so bad in the sense that option E, which is the correct option, was the second most chosen option. So not that bad.
Yeah. So it was still close.
Yeah.
So what actually I'm surprised about this option C because it has like a fraction. Typically, people would tend to not choose options like that unless they solved it to some extent, maybe.
Yeah, there's that, and also it could be, the tendency to choose option C just by random chance, just by
Oh,
guessing.
right. Like in the middle.
Yeah, yeah. So there could be that as well, and yeah,
Yeah, actually that's possible because the options, the distribution is not too, apart from option A, which obviously kind of stands out in a very peculiar way. It's too good to be true, right? So
yeah,
apart from option A, you can see some kind of element of randomness in the choices made actually. So people went for almost everything almost equally. And also D, also most likely based on what you said, also A and D, they're kind of
yeah,
weird. Like they feel like
yeah. They're
out
not
of
degree
the,
2 polynomials.
yeah.
Yeah, degree 1 and
So it
degree
doesn't
0.
feel
So
right.
yeah,
So, but especially A, which is just constant, that is just too good to be true. So I think that makes sense from that angle. Yeah.
yeah, yeah. Okay, so this was an interesting discussion, and hopefully the viewers will take something from this. And yeah, so see you in the next video. See you in the next
See
discussion about
you.
it. Yeah,
Bye.
yeah. Goodbye.